Hey everybody, welcome to my video today on solving systems by combination. This is the third method that we have learned for solving systems, but the book calls it elimination. Same thing, just a different title. Now, how do we do this? There are a few steps. First, step one, line up the equations. You want to have all of the x's above each other, the y's above each other, and the equal signs all lined up, one on top of the other. Second, we want to multiply so that one of the variables will end up canceling out. Now, this is a step that sounds kind of simple, but it actually is kind of a trick. I shouldn't say trick. It's not necessarily a trick like putting a walnut right in here and then cracking it, but something like that. So, what does it mean to have the variables cancel out? Well, they would need to have opposite signs in order to cancel out to zero. One would need to be positive, one would need to be negative, and the numbers would have to be the same. So, if one of them was positive 4, the other would need to be negative 4. This will make more sense when we do an example or two. All right? Now, after we get one of the variables to cancel out, we are then going to combine the two equations together. So, I mean that you will literally smush the two into one equation. Step 4, solve for the remaining variable, and then you will be able to finish the problem just like we did in the substitution method. Okay? Now that might not have made a ton of sense, but hopefully you should go back, maybe rewind, and copy down that list, because you want to have that list in order to be able to do this kind of a problem. Now, if we look at this kind of a problem, and we see that actually, I think we could multiply the top row by -2, and that would get the y's to cancel out. Let's see if that works. So we're multiplying the top row by -2, which would become -2x minus 6y equals +2. Now that we have multiplied, look at the y's. The bottom row that's in green I got that from multiplying up at the top. The middle line that I haven't really touched has a positive 6y. And the green line at the bottom has a negative 6y. See? So, this means that the y's are going to cancel out to 0. And the x's, 3x minus 2x makes 1x, and -1 and 2 combine together to make 1. Now, you can see I've gotten a little too speedy with my work up there, but I got x equals 1. I took x equals 1, and I plugged it into the very top original equation. So, now if I plug 1 in place of x, it says 1 plus 3y equals -1. Now I just need to solve for y like I would normally. Okay? So subtract 1 from both sides. 3y equals -2. Divide both sides by 3. And we will get y equals -2/3. Now, we said we always want to have our answers as an ordered pair. So 1 -2/3 is our final answer. Okay, that was kind of easy to do. The hardest part was probably back in step 1, and it was just deciding to multiply by -2. Let's try another problem that's even harder. Okay. The next problem. Right away, I can see that there's a lot more going on here. None of these variables, neither of the x's, neither of the y's, look like they're going to cancel out right now. If I look at the top where the y is, it's a -4. And if I look at the bottom, the 5y is positive. So I'll be able to cancel them out since they're negative signs, they're opposite signs, but the numbers won't cancel out right now. So that means I'd have to multiply the top by a number and the bottom by another number so that I can get that number with the y's to be the same, just with different signs. Okay? Here's what I mean. If I go through and multiply the top by 5, that would make the y part -20. If I multiply the bottom by 4, that would make the y part +20. -20 and +20 will cancel. Now everything else you have to multiply by the same appropriate numbers. But the important thing was getting one of the variables to cancel. I want to pause there and show what I got when I combined the two lines. The 15x and 16x combined to make 31x. The 10 and the 24 combine to make 34. Now this number, I'm looking ahead, this isn't going to be very nice. Uh-oh. So I'm going to divide both sides by 31. That would give me an x equal to 34/31. Yuck! Now, I have to take that answer of 34/31 and plug it back into one of the original equations. None of them look very good. Well, I think I will just plug it into the top equation and deal with the fractions as they come. So, plug it in, up there in the top, multiply by 3, so 3 times 34/31, don't forget the minus 4y equals 2. And when I multiplied, you can see there in yellow that it's 102/31. Minus 4y equals 2. Now this next part is a little interesting. I went ahead and you can see that my 4y is no longer negative and it's no longer with the 102 31sts. That's because I added 4y to both sides. At the same time, I subtracted 2 from both sides, but when I subtract 2 from that fraction with 31 on the bottom, I made the 2 into 62 31sts. So now I can do 102 31sts minus 62 31sts, and that will be 40 31sts. So you can see there, 40 31sts equals 4y. Divide by 4 or multiply by 1/4. Remember, dividing by 4 is the same as multiplying by 1/4. You can see I canceled diagonally, which is going to leave me with y equals 10 over 31. So by putting it back into an ordered pair, I will get 34 31sts, comma, 10 31sts. And that is the answer to this system, even though it's kind of an annoying answer. So, hope you enjoyed the video. See you in class on Wednesday.